Hello everyone, I'm First Samble Habibis. It's a pleasure to be here with you and share this new video. We will talk about how to repair an issue on i2c line. We will base it on the theory, the calculation and the solution to this very common problem. In this video, we will explain why and how to solve these problems on the PCB. You may remember this video where I repair i2c line with a low voltage value but with transmission. We are going to explain this solution with theory and practice based on official documents and datasheets. The first thing we must understand is how generates the high state of the i2c line. For this we will go to see the official datasheet of Texas Instrument where it explains how it works. Okay, now then we open the document and let's look for who generates the high states. Let's see. Okay, here we see the official document of Texas Instrument understanding the i2c bus. Now we will look for how the binary logic states, so 0 and 1, are controlled. Okay, here we can see a logic block that is to control the states and thus control the communication, an open drain MOSFET transistor and an external pull-up resistor. How does this work? Well, the logic block is the one who controls the MOSFET, and the MOSFET is responsible for making the state change, whether 0 or 1. And now we know that the voltage that the pull-up resistor has at the input comes from the PMU, and we know that the MOSFET are controlled by voltage. Then, if our problem is a low voltage level, this is not problem for of the PMU or the resistor. Rather, it is a problem caused by a leak in the line. We also observe that the transmission signal is generated in both lines, and we have data decoding which indicates us that the CPU is transmitting correctly, only that the voltage level is not appropriate. Okay, Habibis, now we know that the logic states are controlled by logic block and MOSFET, that the voltage received by the pull-up resistors come from the PMU, and that by measure the signal we find a correct transmission of data and clock, but with low voltage. Remember that this equipment already it had swapped when they sent it to try to repair it, and we found the problem with the oscilloscope. Now, to solve it, we must know the tolerance or reference of the pull-up resistors. And for this, we are going to calculate them just as a Texas Instrument document. Now we know what is the values to pull-up resistors should have. Obviously, they have tolerance, and this is why in the theory they give us a slightly lower value than the one they are using on the logic board. This is at the manufacturer ideal standard. Now, if our problem is a low voltage, what we should do is understand Ohm's law. Increasing the value of the pull-up resistors from 2.1 kilo to 4.1 kilo reduce the current flowing through the resistor when the line is high. This allows the voltage to stay closer to the supply voltage, in this case 1.2 volt. The higher resistance helps compensate for any leakage current or degradation in the MOSFET that may be causing the voltage drop, allowing the line to reach the proper high logic level of 1.2 volts. Habibi, I did my best to explain this video in English. You already know that I'm continue to learn this language, and I hope this video is understandable and will be useful for several to understand why I use eigenvalue resistors when repair this problem. Remember that each solution has a reason, and if we pay attention to the details, we can make more solutions. If this video or its content is useful to you, please Habibi, share, like and subscribe. I will try to improve my English and share more information for you. Remember, I am an electronics instructor. I'm not English teacher, but I try to improve every day. Thanks for watching. I'm Fersamble, and see you soon, Habibi. Bye bye.